Hi, good afternoon. This is a video on greatest common factor, and this should be in page 12 of your notebook. So let's get started. Greatest common factor is pretty much just the biggest factor that two numbers share in common. One way to do this is we're going to use prime factorization, and I'm going to zoom this in so we can see this a little bit better. So here are 4 steps that you can use using prime factorization. Use a factor tree or a ladder method to write the prime factorization of the first number. Do the same thing for the second number. List the common prime factors of the two numbers, and then multiply those common prime factors to get the GCF of the two numbers. Here's an example. GCF of 12 and 8. So prime factors of 8 are 2, 2, and 3. Prime factors of 18 are 2, 3, and 3. So the common numbers they have in common, or the numbers that they share in common, are 2 and 3, because see how both of them have that? And then they go right here, and 2 times 3 gives me 6. So we're going to try that right here. So find the GCF of 14 and 21. So what we're going to do is we can do a tree or a ladder. It doesn't matter. I'm going to do a tree with 14. So 14 can be broken down to 2 and 7. Both of those are prime, so I'm going to circle them. 21 can be broken down as 3 and 7. Both are prime. The two numbers that they share in common, or sorry, the number that they share in common is 7. And that's it. So 7 is the GCF. All right, now we're going to do 12 and 18, which is the example above, but we're going to do it ourselves. Let's do a factor tree. So 12, we can break that down as 2 and 6. Since 2 is a prime factor, we're going to circle it. 6 is not, so we're going to keep going. This gives me 2 and 3. We're going to circle and circle. We're going to do the same thing for 18. I'm going to break that down. I'm going to use 3 and 6. I'm going to circle 3. I'm going to break down 6 to 2 and 3. And then I'm going to underline what they have in common. So this is a 2 and a 2, so they share a 2 in common. They share a 3 in common. And they don't share anything else in common because that's a 2 and that's a 3 and those aren't the same. And 2 times 3 gives me 6. So 6 is the GCF. All right, the third example that we have is 30 and 75. So let's break it down. So 30 I have as 3 and 10. 10 I'm going to break down to 2 and 5. 75, I'm going to go over here. I'm going to break that down as 3 and 25. And I'm going to break down 25 as 5 and 5. I'm going to underline what they have in common. They both have a 3. So I'm going to bring that down. They both have a 5. And they don't have anything else in common because that's a 2 and that's a 5 and those aren't the same. So that gives me 15. So 15 is the GCF. All right, let's open up on the inside. This is a second way to do GCF. You're going to list the prime factorizations of each number. You're going to write the common prime factors in the center of the Venn diagram. Then you're going to multiply those common prime factors to get the GCF. So for example, they used again 12 and 18. They broke down 12 as 2 times 2 times 3. They broke down 18 as 2 times 3 times 3. So then, using a Venn diagram, you guys have used them before. Inside the circle for the 12, I'm going to use a color to kind of show that. So let's do this. So let's talk about 12. So 12 is 2, 2, and 3. So 2, 2, and 3. 18, I'm going to do in blue, is 2, 3, and 3. And the reason why these are both in the middle is because they have them in common. And then you take the 2 and the 3 and you multiply them to get 6. Okay. All right, so let's do 2 examples. All right, 15 and 45. So draw your 2 circles.
Just a reminder to all students who are planning on attending this afternoon's football game, you are to be in the cafeteria no later than 2:30. Once again, all students planning to attend this afternoon's football game
Sorry
are
about
to be in the
the
cafeteria
interruption.
no later than 2:30. Thank you.
All right, so if you're going to the football game, you heard that announcement. Here we go. All right, so 15 and 45. So what I'm going to do is I'm going to list my factors of 15 over here. So I'm going to do a little factor tree down below. So I get 5 and 3. I'm not going to put them in the circles yet. And then 45 I'm going to do down here. I got 5 and 9. I could circle 5, but I need to break down 9 to 3 and 3. And so now we're going to see what they have in common, and whatever they have in common, we're actually going to put in the center. So they both have a 5. So let's put the 5 in there. And when we use it, let's go ahead and cross it out. And then they both have a 3. So let's put a 3 in the middle. And then we'll use it and use it. Now 15 doesn't have any more, so we don't have to put anything in there, or we could just put a 1 if you want. And then this guy does have a 3 in here. So what's their GCF? Their GCF is that middle piece, and I'm going to highlight it for you. So that's their GCF, their greatest common factor, because they both share 15 in common. So let me see. So the GCF is 5 times 3, which is 15. All right, let's do another way. Or another one, sorry. Let's do 56 and 40. So 56 and 40 go here. All right, so 56, we're going to break it down. I'm going to break it down with a tree over here. I'm going to break it down by 2 and 28. 28 is 7 and 4. And 4 is 2 and 2. If you chose to break down 56 as 7 and 8, that's fine. Okay. Remember, you can always do a tree however you want, as long as you always end with prime numbers. So 40, I'm going to choose 4 and 10 instead of 2 and 20. But again, you can always do whatever numbers you want. So 4 is 2 and 2. 10 is 2 and 5. And now I'm going to see what they have in common. So this guy has a 2 and that guy has a 2. So let's put a 2 right here. This guy has a 7, no 7 over here, so I can't put that in there. This guy has a 2 and that guy has a 2, so let's put another 2. So let's cross those out once we use them. Another 2 and another 2, so let's put that in there. And then nothing else. So this guy has a 7, so let's put them over there. And this guy has a 5, so let's put that over there. And then the GCF, again, is that middle piece, which is 2 times 2 times 2. Which gives me 8. All right, and that's how you guys can find GCF. I am going to show you one other method if you want. I feel like it's probably the easiest. The reason why I'm showing you this way is because this is actually going to help us with LCM later. But let me show you just one other way. Here's a third way to do something. So if you just do 56, if you list all of its factor pairs, so 1 and 56, 2 and 28, let's see, 4 and 14, 5, 6, can't go into it, 7 and 8, and then you list the factors of 40.
Good afternoon, staff. The leadership team meeting will start in room 220, again, at 2:30. So, leadership team meeting will start at 2:30 in room 220. Thank you.
All right, sorry about that. All right, and then this is method 3 that I'm showing you. Okay. So I literally just made a list, and all you're gonna do is find the biggest number that they share in common. So let's see the biggest number that.
Excuse me, I think that's the department chair meeting. Again, the department chair meeting at 2:30 in room 220.
And guys, I'm very sorry about all the interruptions. It is because it's right after school, so I apologize for that. And the biggest number that they both share in common looks like an 8. which is, look, that's what we got when we did the Venn diagram. Okay, so that was just a third method to do. All right, so your homework for tonight is I want you to, for all these factors, actually for 1 through 12, all you have to do is just give me all the factors of these numbers. Okay, you don't have to do a prime factorization or anything. But then when you come down here, I do want you to find the GCF of 12 and 18, 7 and 42, and then so on and so forth, so 9, 10, 11. So I do want you to finish these questions on here. All right, thank you so much. Have a good night.